The question of what existed before the Big Bang has intrigued scientists, philosophers, and curious minds for centuries. This question does more than challenge our understanding of the universe, it presses against the very boundaries of human knowledge. Imagine, for a moment, standing on the edge of existence, staring into an infinite void, and wondering what lay there before the birth of everything we know. What preceded the Big Bang? Could the universe have simply erupted from nothing, or was there something even more mysterious at play long before time itself began? The Big Bang, as we understand it today, marks the explosive origin of space, time, and all the matter and energy that make up our universe. But the deeper you dig into the fabric of reality, the more you begin to wonder, was there a state of absolute nothingness before that moment? Or did the universe emerge from something far more strange and complex than we can even imagine? One of the foremost voices on this subject, physicist Brian Cox, challenges us to reconsider our most fundamental assumptions about the nature of reality. He suggests that something extraordinary might have existed before the Big Bang, something that could forever alter our understanding of existence itself. This hypothesis doesn't just push the boundaries of science, it encourages us to contemplate the very essence of time, energy, and matter. To delve into this question, we need to explore mind-bending concepts such as cosmic inflation, quantum mechanics, dark energy, and even the possibility of an infinite multiverse. These ideas don't just make us think, they shatter the walls of our understanding, leading us toward an ultimate question: what was there before the beginning of everything? To explore the concept of what existed before the Big Bang, we must first understand what the Big Bang actually was. Contrary to how the phrase might sound, the Big Bang wasn't an explosion in space, it was the sudden expansion of space itself, from a singular, infinitely dense point. In the instant it began, the universe began to cool and spread, eventually giving birth to all of the matter and energy that we observe today. This event set the stage for the cosmos, with galaxies, stars, and planets forming over billions of years. But, as remarkable as this event is, it leaves us with an equally profound mystery: what caused the Big Bang to happen? And was there a moment before it? The theory of cosmic inflation provides a startling answer. It suggests that, before the Big Bang, the universe existed in a state of extreme cold and emptiness, a vast, frigid vacuum. Yet, this vacuum wasn't entirely empty. Instead, it was filled with an immense amount of potential energy, which triggered the universe's rapid expansion in what is known as inflation. Inflation didn't just stretch space, it expanded it at an unimaginable rate, turning a region smaller than an atom into a vast expanse almost instantly. This rapid inflation laid the groundwork for the universe's creation. But why did this inflation stop? And what was the nature of the energy that caused it? Could it be that the universe was simply a byproduct of this energy, or, perhaps, there was a deeper force at play? The concept of inflation leads to one of the most mind-boggling ideas in modern cosmology, the inflationary multiverse. What if the Big Bang wasn't a unique event, but part of an ongoing process of creation, one that happens repeatedly across an endless multiverse? The inflationary multiverse proposes that our universe is just one of many, each emerging from its own Big Bang, expanding, and evolving in its own distinct way. In this scenario, space is constantly growing, like a fabric stretching to infinity, with each bubble representing a new universe. This theory suggests that our universe might be just one tiny speck in an infinite ocean of universes, all created through their own Big Bang-like events. This notion forces us to re-evaluate everything we thought we knew about the cosmos, as it implies a reality far grander, more mysterious, and more interconnected than we can fathom. As we venture deeper into the nature of our universe's origins, another perplexing question arises: what about dark energy? This mysterious force, which is currently responsible for the accelerated expansion of the universe, raises intriguing possibilities. Could dark energy have existed before the Big Bang? Could it have been the catalyst that drove the rapid expansion during the inflationary period? Some scientists argue that dark energy is not just a feature of our current universe, but could be a remnant of a vast energy field that predates our cosmos. In this view, dark energy might not only shape the universe's current expansion but could have played a pivotal role in triggering the Big Bang itself. If dark energy existed before the Big Bang, it might have been the quiet architect of the universe's birth, shaping the conditions that led to the creation of everything we see today. Yet, this raises a paradox. If dark energy existed before the Big Bang, could it have somehow designed the universe we live in? And could this force exist beyond the scope of our universe, potentially unlocking the secrets of the multiverse itself? When we consider what existed before the Big Bang, the concept of nothingness quickly becomes a topic of great confusion. In our everyday understanding, nothing means the absence of everything, no particles, no radiation, no energy. However, the reality of quantum mechanics complicates this notion. Even in a perfect vacuum, what we might consider nothing, there are still quantum fields that exist. These fields are far from empty, they are constantly fluctuating, creating and destroying particles in a perpetual dance. This phenomenon, called quantum fluctuations, suggests that the universe cannot truly be empty. Even if all matter and radiation were removed, there would still be something: energy fields, quantum forces, and the potential for particles to emerge spontaneously from the void. This idea challenges the concept of a true void and suggests that what we call nothing is, in fact, teeming with activity, albeit on scales far beyond our perception. One of the more radical ideas in cosmology is cyclic cosmology, which proposes that the universe is not the result of a single Big Bang, but part of an endless cycle of creation, destruction, and rebirth. In this model, the universe goes through repeated phases of expansion and contraction, each Big Bang marking the beginning of a new cycle. Each universe is born, evolves, collapses, and then gives way to another, in an infinite loop. According to this hypothesis, there was never a true beginning to the universe. Instead, the cosmos is in a perpetual state of flux. Universes are continually born from the remnants of their predecessors. If this theory holds true, the idea of before the Big Bang becomes irrelevant, as time itself could be part of a never-ending cycle, with no true beginning or end. In recent years, gravitational waves, ripples in the fabric of space-time caused by massive objects like black holes or neutron stars, have opened up a new frontier in our understanding of the universe. These waves carry with them a wealth of information about the universe's most extreme events. Could they also provide clues about what existed before the Big Bang? Some scientists have speculated that gravitational waves from the time before the Big Bang could leave behind subtle traces of information about the universe's origins. These waves might be echoes from a past universe or remnants of a pre-Big Bang event. Such signals could potentially offer a glimpse into the mysteries of the cosmos before inflation began, further expanding our understanding of what lay in the vast nothingness before the birth of our universe. One of the most profound questions raised by these theories is the nature of time itself. Our current understanding tells us that time began with the Big Bang. But what does it mean for time to have a beginning? Could time itself have been part of an eternal, cyclical pattern that transcends our conventional understanding? In theories such as string theory, time and space are not fixed entities but are instead part of a higher dimensional reality that we cannot fully perceive. If this theory is correct, then our universe might be just one slice of a much larger, more complex space-time structure. The Big Bang could have been the result of a convergence of higher dimensional forces,